And this is really important for the climate system. So this aerosol optical depth is one of the primary parameters observed by the satellite. And here you have a picture of the NASA satellite called MISER, showing you climatology for over 10 years of the aerosol optical depth. So this is reality, not model. So basically, it uses the sunlight reflected by the Earth's atmosphere system. And after many corrections about how the surface reflects the sun and how the clouds and so on, then you can extract the signal only due to aerosols and derive this aerosol optical depth. So from this picture, we can see that most of the aerosol optical depth is dominated by the dust and by mass building emission over the world. And you can see a very strong signal over China due to pollution, India in the Ganga Valley, and the Middle East is also dust. So we can also measure this parameter very quite easily. And even for scientific, it's really useful. And so we use this very small photometer that you will see after, which measure the direct attenuation of the sun. And so from this attenuation, you derive the aerosol optical depth. And we deploy it in Africa because in this part of Africa, it's really difficult to have large scientific equipment and so on. So we ask the student, the middle school student, to make the measurement for us. And it's worked very well. We have a lot of measurement. This is one example for the city of Cotonou in Benin, in southwestern Africa. So it's a time series of the aerosol optical depth from December for over about 3 years. So you can see the time evolution of this parameter. During the dry season, you have a lot of dust coming over the city because this city is located just southward of the main source of dust in Sahara. So during this period of time, in the dry season, in January, February, you have a lot of dust coming to the city. And if we look at the spectral dependency, then we can see this spectral dependency. This is the Angstrom exponent, which gives an idea of the spectral dependency of the aerosol optical depth. We can see a drop in this parameter, which indicates us that we have dust on the site. While during the wet season, we have less measurement because of clouds. We can only measure without clouds. And because also of the rain. The rain is the main phenomenon that scavenges the aerosols. So you have a drop in the number of particles and the drop of any other parameter. While during the other, we have a secondary dry season, and during the secondary dry season, we can see the accumulation of pollution over the city with a very high Angstrom exponent, which indicates we have fine pollution particles. So this kind of measurement is really interesting to understand the aerosol behavior and change for a given point. So aerosol optical depth is a primary important parameter to understand how the aerosol impact the climate, because you have different interaction between the aerosol system and the climate. The first one is really the interaction with the radiation. So because of this optical depth, these optical parameters, the pollution aerosol will reflect the sun back to space and so cool the planet, which is called the first direct effect. It's also interact with the clouds because the fine particles will make cloud droplets. And the more particles you have, the more droplets you have, but they are smaller. So they change the microphysical properties of the cloud. This is the indirect effect. Because they deposit, then they can't stay in the atmosphere for thousands of years. It's a short-lived species. Because of their deposition, as we said before, they will change the reflectance of the snow in the poles. So they make the snow darker, which means more absorption of the sun on the snow. And because they deposit everywhere, they can give nutrients to water, ecosystem, and so they have a large impact on ecosystem, especially for remote ecosystems which have no other source of nutrients, like open ocean or some lakes. So we'll not go into the detail of this big picture, just to show that from the interpanel on climate change, we contribute to assess how the aerosol impact on climate. So there is some estimation, and you can see this is really one of the primary components of the climate change. Not as strong as the CO2, of course, which is the main factor for climate change, but it can, in a way, counterbalance the global warming of CO2. Not for all type of aerosol. If we look especially at the black carbon, the emission from combustion, you can see that there is some positive forcing. So it's like a warming like CO2. So this black carbon is really one of the species we are targeting. And moreover, we are targeting this species because we know that the fine particulate matter is really harmful for health. You have a lot of disease now, it's well established. There are many diseases linked to exposure to pollution, and especially to PM2.5, the finest particles, with a respiratory problem, COP, which means chronic obstructive, yes, that's it. So the World Health Organization set some threshold about the exposure. It must be below this 10 microgram per cubic meter. However, there is no real threshold on exposure. We know that even for smaller exposure to this threshold, there are some effects. We are really interested in targeting black carbon and combustion aerosol because we know that black carbon maybe not the most dangerous species, but it's come with other bad guys like PAH or heavy metal and many toxic elements. So it's like an indicator on how the on the toxicity of the aerosols. And okay, just to say that depending on the city where you are living, then you don't have the same exposure, and especially in developing countries, or it's now a really huge problem of health because of the exposure to the PM2.5 and the combustion aerosols. Okay, so I've talked about that already. It's about the black carbon and how it impacts climate and health. So just a word about what we really call black carbon. It's like a definition, optical definition. Black means that it absorbs radiation, so it's look black. But I said before, aerosol is a complex mixture. It's not like black carbon, then something else, and something else. So you have like a continuum between what is black and what is orange. You remember the filters. And we put like a threshold on the light absorption properties of the aerosol to say we have a fraction of black carbon, and then it goes to something like brown or yellow carbon. There are other definitions of this parameter, and we use the thermal optical classification, which means the black carbon is the more refractory part of the aerosol. And I will talk this because we use this method in the laboratory. The main sources of the black carbon in the atmosphere is, as I said, open biomass burning over the world. Then from the residential cooking. And this is really important in developing countries because they use a lot of biomass to cook with not really well-designed oven. And there are many programs to improve the use of biomass burning in the developing country. Of course, transport with the diesel. In France, we know diesel very well, maybe too well. Now, I've changed my car recently, and everybody will change the car in the near future. Yeah. Or you have a bike, so no. You have a car? Because we are really interested in the black carbon, we want to measure it. And so we use very expensive scientific instruments, and we also use a very simple instrument and work with the school. And we have one advantage of the satellite that we can really measure black carbon, while the satellite, there is no black carbon product. So the physical principle to measure the black carbon is to collect the aerosol on a filter and then measure the transmission of the filter at a wavelength where most of the wavelength is absorbed by black carbon. So from this collection and the change in the attenuation, we can derive the concentration, atmospheric concentration of the black carbon. So usually the concentration, atmospheric concentration, varies between 100 of nanograms per cubic meter if you are a very clean environment like this Pic du Midi I showed you before, upper mountain, to a tens of microgram if you are doing a barbecue or very close to your diesel car. So we did a test with the my feet. Okay. we did a test with the middle school pupils. We asked them to make the measurement with the teacher, of course. We asked them to make the measurement. So we have very small filters, and we collect a punch in the filters to make our analysis. So we have 1, 2, 3, 4, 5, 6, 8 middle schools. So they did a really good job. So they give us all their filter, and we analyze in the lab with this big machine the fraction of elemental carbon and the fraction of organic carbon. With this small accelerometer system, you only have the fraction of black carbon. You don't know exactly the apportionment between what is black and what is organic. And this, however, this ratio between organic and elemental carbon is a very good indicator of what kind of combustion is originally emit the aerosols. So we have 70 filters with an exposure time of 29 days, mean exposure time, which means that the pollution was very weak. It was during autumn, and the average concentration was about 450 nanograms per cubic meter, which is very low concentration. In Toulouse, we are much closer to 1,000 nanogram per cubic meter. And when we compare to our measurement, we find a quite interesting, quite good, actually, relationship. And especially, we need a conversion factor for this because we make optical measurements and we need to convert it into physical measurements. And we were able to say that the converting factor that we use is very close to previous study and that the instrument was working quite well. And moreover, we did the analysis of the ratio between the organic and elemental carbon, and most of the measurements were taken in a range of urban emission dominated by traffic. So now we are more interested to shift toward something more dominated by biomass burning aerosols like crop waste burning or wood burning and so on, to see if the instrumentation is also well working. So this is the end, and just to say again that aerosol is a key component of the climate system, and so we need to better understand how they interact with the whole climate system. Clearly, the aerosols are harmful for health, and there is a lot of programs to reduce emissions, and also that they can really observe by using very simple physical principles with samplers to make measurement of optical depths, BC, also very simple tools to measure the PM, particulate matters sampler. So thank you for your attention, and I'm still here to answer your question, if any.
The question on the black carbon equipment.
Yes.
Is it easy to make? And if we were to measure it, could you analyze our samples?
Easy to make by yourself, you mean? Or
in schools, or is that
to build the instrument or to make the measurement? To build the instruments, not so easy. So there is one company that built the instrument for us. But actually the design is very simple. So probably you can make by yourself if we give you the indication. Then analyze the measurements. Yes, we can do that. There is one, but Daniel will talk about that. There is one program next year for a field campaign that we.
Next year.
Yes, we want to make a new measurement. It's well, well, I said that most of the school they place the sampler indoor in the classroom and make a pipe with a pipe collect the aerosol. So they sample the urban-like atmosphere. But the idea is really to also to sample different kind of environments, including indoor environment when you have a chimney or wood burning to see how the concentration and how it varies. And I didn't mention it, but with these instruments, because you monitor the change in attenuation, you can have a time series of the concentration. So here we only analyze the filter at the end of the sampling period, but you can monitor the concentration as a function of time with a step of a few minutes. You can use different type of filters, but if you want us to analyze, then we must provide the right filter to you.
After you have collected the filters, then you put it in a big machine.
Yes.
That is? What kind of machine?
What's the machine?
Yeah.
This is the thermal optical system. So you put the filter inside and then you heat the filter. So you first you use different gases like air, oxygen, and helium. So you dissolve all the organic. Organic are first evaporated. Then you still burn, and then you have the elemental carbon. So you make a step in temperature and remove all the material on the filter, and you measure the CO2 emission to have the concentration of different kind of organic matters, then different kind of elemental. This machine is laboratory equipment, very expensive, yes. But it's actually there is no international. There are some agreement on how to measure this combustion aerosol, but there is no international agreement rules on the black carbon monitoring because it's a very complex system.
Bring their samples to laboratory, or they have this expensive machine in the school?
No, not in the school. No. That's why we make this collaboration with the school and ask them to make the sample, look at that measurement, okay, with this optical signal, the attenuation, then give us back the filters to make the analysis on the filter to see what is really the fraction of elemental and organic carbon on the filter. No more question? Yes.
Do you have any experience with doing black carbon measurements in snow?
No. No.
Somebody in the States, in Colorado, is doing that. We've been wanting to integrate that into our school.
That could be really interesting, but not in my laboratory. We do it in France, in Grenoble. So they collect the snow, melt the snow, then make the measurements with the same kind of techniques. Just melt the snow and filter the liquid and collect the particle matter. But we don't do this in my lab. But it can be done, yes. And with the school, I don't know, yes.
Is it more for the purpose of the climate change element you're measuring the black carbon, or more for the health impact? Because it's my understanding aerosols are at a higher, we're taking that measurement at a higher level than, the air quality we breathe, say.
Yes, actually I said the black carbon is really important for both climate change and air quality. But this kind of measurement maybe is more dedicated toward air quality because it's really the air we breathe, okay? So you can't really derive some information on the climate impact. So it's more dedicated to health and air quality, I would say.
But would it complement the Calisph'Air measurement then, which would be
Sorry, though?
You know, the calitube, which takes the measurement at the higher
Yes.
level. So you're, by doing this as well, you're maybe complementing that measurement?
Exactly. You can compare the two kind of measurements, and especially with this spectral shape dependency. If you see that you have a lot of pollution aerosols, you can make some hypothesis that you have a given fraction of black carbon then is well distributed in the atmosphere, at least on the lower part of the atmosphere, and then work on this this black carbon impact on the climate. Yes.
So thank you.
Thank you very much.